Hello again and welcome back to our programming courses in Yamagata University. This is the 7th session in the second course, which speaks about algorithms and data structures, and in this second part of the course we are speaking about algorithm complexity. In previous sessions we defined intuitively and with a bit more theoretical detail what we meant by the complexity of an algorithm. We gave the idea that mostly we are interested in how the time of the algorithm changes. Usually it grows when the size of the data grows. We saw in previous sessions different complexity classes: linear complexity, constant complexity, and quadratic complexity, and we stopped quite a bit on how to compute the complexity of one algorithm by following the trees of execution and considering the worst case scenario of how many instructions would be run for every size of data. In the previous session we also introduced the sorting problem, where we will be sorting lists of integers and trying different strategies, different algorithms to solve the problem. That also allowed us to speak about optimal algorithms. Basically, when we have a problem, we can solve it in many different ways, and the algorithm that solves the problem, that has the least asymptotic complexity, is what we call the optimal algorithm. Every time we check the complexity of an algorithm, we also ask ourselves whether or not that's optimal. Today we will be speaking about recursive programming, so we will be stopping our sorting algorithm exploration for a little while, for just this session, and we will use the time to think about recursive programming, which is a new technique where, as we will see, the main thing is that the function that we are coding calls itself. That amounts for very compact code, which in some occasions is rather slow and in some other is actually very good. We will be seeing the definition of recursive programming, how that relates to the mathematical principle of induction. In this section we will be coding quite a lot of recursive algorithms, and we will be thinking about their complexity. That last bit will allow us to consider different complexity classes that we have not yet seen, and we will also concern ourselves with whether or not the algorithms that we design are optimal.